Bismillahirrahmanirrahim. Welcome to Chandbagh School Physics Department, Grade 11, Lesson number 4. Dear students, today we are going to use the Ohm's Law and we will define and we will see the graph of the Ohm's Law. Uh, the Ohm's Law, we have already discussed that it relates with voltage and current. So, before we discuss the Ohm's Law, we will discuss the simple circuits and then we will formulate the equation. So in this lesson, we will discuss the simple circuits, Ohm's law, its equation, and ohmic graph. Dear students, you can see in this diagram as a very simple circuit connected with a battery, switch, and bulb. This light bulb can be considered as a resistor. So when we talk about the simple circuit, it consists of a single resistor and a cell or battery with a switch. When voltages are applied through the battery, its current passing through the bulb when switch is on, and if we increase the current, if we increase the battery voltage, the current is also increased. If we decrease the battery voltage, the current will decrease. So in this case, we can say that the voltage and current, they are directly proportional. But here the condition is that the resistance must not change. The resistance of this bulb must not change. If the resistance changes, then the voltage and current might not be proportional to each other, directly proportional to each other. Because with the increase of the resistance, current will decrease. So voltage is directly proportional to the current, like this equation. Resistance remains same. This is the condition. If the resistance varies, then the current and voltage does not remain directly proportional. Now, if, for example, if we have three bulb in a series in the circuit, like in the same, let's say same battery, it means voltage remains same, but the now we have three resistors in series. In series, the resistance is increased and add up. So if the voltage cell or battery remains the same and three resistors are connected, the total resistance will increase. That is R is equal to R1 plus R2 plus R3. Then current decreases. So V is not proportional to the current if resistance increases or decreases. So we can say that resistance, current and voltage will be only directly proportional when the resistance of the circuit remains constant. Alright. So when we want to define the Ohm's law is that current through an ideal conductor is proportional to the applied voltage. So the voltage will be current multiplied by resistance, or V is equal to I multiplied by IR. V is the voltage and unit is volt, I is the current, unit is ampere, and R is the resistance and unit is ohm. So dear students, this is the equation of the Ohm's law. Now again, we take the simple circuit and we say that what's meaning of ideal conductor? So ideal conductor or ideal resistor. This is the a resistor in the circuit, and V is a voltmeter, A is ammeter. An ideal conductor or resistor is a material whose resistance does not change with temperature. Like in case of bulb, Uh, you see, with the passage of time, when if we, here is a bulb instead of resistor, it is a bulb, then it also produce heat along with the light. So the electrical energy is being converted into two forms, that is heat energy and light energy. So what will the heat will do? Its temperature rises. If the conductor is ohmic or ideal, then its resistance will remain same. But if the temperature, with the increase of the temperature of the bulb, its resistance also increases, then it will become non-ohmic or non-ideal conductor. Okay. In case of ideal conductor, the graph between voltage and current is always a straight line. So voltage and current are linear when resistance is held constant. All right. So this is called the graph of Ohms. And in case of non-ohmic graph, if the bulb is used for a longer period, then due to large heat produced, its resistance increases and current decreases. So graph will not be a straight line. So this is called non-ohmic law. Thank you very much. In the next lesson, we will discuss